Welcome to this week's Inland Empire Math Circle. Today we'll be going over a few AMC problems. And these problems will mainly be about circles. And for the first half of the class, we have four questions. And during the later half of the class, we're going to be working on some interesting math puzzles. So the first problem that we're going to work on is this one. I'll give you guys about 1 minute to read this question, and then we'll do this one together. All right. So time's up. Loy, can you tell me what the question is asking for? Loy?
What the area of the triangle?
Yeah, that's correct. And how do you think we're gonna use the circle here to find the area? Because there's a circle inside the triangle, so we must use some characteristics of the circle to solve this problem. Loy? All right. I'll walk you guys through this problem first. I'll give you a hint first. So all right, Loy. Do you think I gave you some hint on the problems. Do you think this makes it easier for you to solve it? Loy? All right. Do you want to give this question a try? Do you think you could find the solution to this answer now? All right, I'll do this one. So we see that this part is basically the radius of the circle. And then so because the radius is basically the center point of the circle to any side on the circle. So this side of the circle is basically connected to this side of the to CA of the triangle. And thus we could basically say that this part equals to the radius of the radius of the circle. And to find the radius of the circle, we need to use the area of the semicircle. The area of the semicircle is 2 pi, which means that the area of the full circle is two times the area of the semicircle, which is 4 pi. Joyce?
Yes.
Did you guys learn about the equation of how the equation of the area of the circle?
No.
No? Oh, okay. Well, the equation for the area of a circle is pi which is 3.14 times r squared. And r, in this case, means the radius, which is basically the center point of a circle connected to the circumference of the circumference of a circle. So these lines are all the radius of a circle because it connects the center point to the circumference of the circle. Does that make sense?
Really?
Okay. So since the area of the circle equals to 4 pi, we can basically tell that r squared equals to 4, which means that if r squared equals to 4, r basically equals to 2. So this side equals to 2, and this side also equals to 2. Do you guys know the answer to this to the question now? So this part here is 2. This part here is also 2. Do you guys think you can figure out the answer now? Lloyd? Well, all right. Well, to find the area of the triangle, what we basically have to do is that we see that this part becomes a square, which has an area of 2 times 2, which gives us 4. And we also have 2 triangles here, which has a sine length of 2. So these 2 parts are 2, which means that equals to a half 2 times 2 plus the same thing again, because there's also a triangle here. So have 2 times 2. And this gives us basically 4. So the answer is 4 plus 4, which equals to A. And our answer choice is B. Do you guys get this question?
You lost me when you kept on adding the 2's.
Sorry, Joyce. Can you say that again?
I understand everything except for the part that you kept timesing the 2's, and I don't know.
The part?
Yeah.
Oh, this part is basically do you know what's the formula of the area for the area of a triangle? It's a half times the width
Yeah.
times the length, right? So take a look at let me draw this again. Take a look at this triangle right here. What do you think's the width and length in this case?
So 2 times 2.
Yeah, and then don't forget the 1/2. So
Oh,
the area of this thing right here is basically 1/2 times 2 times 2. That's how we get the area of this triangle. And we also have to do the same thing for the other triangle, remember? Because we're adding up the square, which is this part, and the lower triangle, which is this part, and then the upper triangle, which is the last part. Do you get it now?
yeah.
All right, cool. Shall we move on to the next question? All right. This is the next question. I think this one is actually pretty easy. So I'll give you guys 1 minute to read this question. And then yeah. All right, let's take a look at this question. So a circle of radius 2 is cut into 4 congruent arcs, which is basically these 4 arcs. Like a part of the circumference of a circle is basically called an arc. So these are the 4 arcs. 4 arcs are joined to form the star figure shown below, which is this one. What is the ratio of the area of the star, this one, to the area of the original circle? All right. Do you guys have any idea to how this problem should be solved? Lloyd, Joyce? All right. I guess I'll walk you guys through this problem. Wait, Joyce, are you about to say something?
No.
Okay. So radius of 2. So we just learned that the area of a circle is pi radius squared, right? And in this case, the area equals the radius equals to 2, which gives us the equation that the area of the circle equals to pi 4 pi. Because when you plug in the 2 into r, you get 4. That's 4 times pi, which is 4 pi. And that's the area of the circle. Now, what is the area of the star? I'm gonna draw this to make it more obvious. It's essentially the area of the star is essentially a square minus the circle, because if you put these part together, it'll become a circle, right? Each of these unique shapes, it's basically 1/4 of a circle. So when you put these 1/4 circles together, you'll get a full circle. Joyce, can you help me calculate the area of this star?
Okay.
So keep in mind this is a square, right? And then this part, the radius, which is this part, is 2. So from here to here, it's a 2. From here to here, it's a 2 again. So it's a 4, right? Because it's the same thing for like all sides. This part is also 4. So what is the area of this square?
The area of the square is 4 times 4.
Which is
16.
Yep, 16. And now we have to minus these parts, right? What is the area of these four unique shapes? Can you tell me what is equal to, Joyce?
So the side, wait. I don't know.
Okay. So we talked about this, right? If you put these four parts together, see, like this is one part, right? This is another part. The part. The part. If you put these four parts together, like if you squish them together, what shape would this become?
Circle.
Yeah, circle. And then since they all have the same radius, it means that when you put these four quarter circles together, you'll get the area which is equivalent to this circle, right?
Yeah.
So what is the area of this circle?
4 pi.
Yeah. So the area of the star to the area of the circle is 16 minus 4 pi over the original area, which is 4 pi. And if you divide top and bottom all by 4, divide this by you divide this part by 4 and divide this part by 4, you'll get 4 minus pi over pi. That is answer choice 1. I mean A. All right. Do you guys get this problem? Loy, Joyce?
Yeah.
This is the third question. All right. This question is pretty hard, and I'll give you guys 2 minutes to read this problem, and then we'll look at how we're going to solve it. All right. Let's look at this question. A ball with a diameter of 4 inches. I'm just gonna draw. Just gonna. Ball, which is this one. It's 4 inches in diameter. And it's rolling at point A, so starts at point A and then rolls along the track shown. The track is comprised of 3 semicircles arcs whose radius are R1, which is 100 inches, R2, which is 60 inches. So the radius, this thing, is 100. The radius of this thing, 60. The radius of this thing is 80. The ball remains contact with the track and does not slip. So it always, what this means is that it always sticks to the surface of the track. What is the distance the center of the ball travels over the course from A to B? Now, this question might look easy because you would think, oh well, isn't this just circumference of the 3 circles added? Well, if that's what you think, then you're wrong, because it's actually more complicated than that, because it asks you for the center of the ball. So you have to consider the fact that there's a 2 centimeter 2 inches gap between the center of the ball and then the surface of the ball. So you have to keep in mind that the surface of the ball is 2 inches from the center of the ball. So when you do the circumferences, you have to make slight adjustments so that the results will be accurate. Let's do this one. So here's the center of the ball. Loy and Joyce, have you guys learned about how to calculate the circumference of the circle?
No.
No. Well, the circumference of the circle equals to 2 pi r, which is 2 times the radius of the circle times pi. So for this one, it's 2 times 100, right? The radius of the circle is 100. So what would be the circumference of this semicircle? Joyce?
Yes.
The area, the circumference of the circle, which is basically this part. It's a line. It's the length of the line around the circle. So if I ask you what is the circumference of this circle, it will be this part around the circle. So currently we have R1, which is a shape that has a radius of 100, and we're asking for circumference of this thing. What will be the circumference? This is the equation. It has a radius of 100. So just plug R as 100 and times 2 and then times pi. What will be the result, Joyce? Let me write it out for you. It's 2 times 100 times pi.
What?
Because this part R, this part is R, right? Can you read my handwriting? This part is R and it's 100. So it's 2 times R times pi, which is 200 pi.
Oh,
That's the circumference. But then you have to divide this part by 2, because then if you're calculating the circumference, you're calculating the side, the length of the whole circle. This is half a circle, so it's 100 pi. And 100 pi. And now we're going to calculate what's the distance of the center that the center of the ball had traveled. If you look at the center of the ball, it's essentially going like this, right? There's a 2 centimeter gap between the circumference of the circle and the ball. So actually, we could see that the radius of the smallest circle, which is how much distance the center of the ball traveled, is the radius of the big circle minus 2. So it's 100 minus 2, which is 98. This is the radius of this part, which is the center of the circle to the track that the center of the smaller circle traveled. Does this make do you guys understand this? 98. This part is 98. Do you guys understand this? All right. So this part is 98, and then after we did the same process, we'll get that 98 is the circumference of this thing. And then we go on to this part. Now this part, this is pretty tricky because you would think that we're going to minus 2 from 60 to get the radius of the circle, right? To get how much the center of the circle traveled, right? Like the radius. Can anyone tell me why this is wrong? Loy, Eric, do you guys know why this is wrong? Just say what you think. Don't be afraid to make mistakes. Eric, Loy, no? Joyce, can you tell me why you think that simply subtracting 2 from 60 is not going to give us the radius of this arc right here? Because we're minusing 2 from the radius for these 2 circles, right? What is the difference between these 2 circles and this circle? So we're being asked, what is this? Is this and that the center of the ball travel, right? It's gonna be like this. Because there's gonna be some distance between the center of the circle and then the surface of the circle. So basically we could divide these into three parts. For the first part, it's going to be the original radius minus 2 because it's actually traveling less distance, right? But after you reach this point, it's actually going more than R2's radius. It's going more, right? So you have to plus 2. So this part originally is 60. So after we plus 2, the radius becomes 62. And then the circumference of the semicircle is going to be 62 pi.
Stupid.
And then for this part, we do the same thing. And then it's going to be 80 minus 2, which is 78. And this is going to give us 78 pi to find the circumference. We plug these results into a calculator, although in an actual AMC, you would have to calculate this by hand, but I think it's pretty easy. So I'm just going to use a calculator. You're going to get 238, which is the first choice. All right. Now Professor Eric will help you guys with the rest of the problems. All right, Professor Eric.
Okay, thank you, Professor Ma. So for this one, basically I'll just, the idea is that you have 3 different circles and a rectangle is connecting all of their centers. But also we have a point D, which is on a point on that other circle. So does anyone know what the definition of a rectangle actually is? Like the specific definition of a rectangle? So in a shape, we have 2 different kind of like properties of a shape. We have the sides of the shape, and we also have the angles of the shape, like the points on the side, like, sorry, just wait 1 second. Like these are the angles. So does anyone know what the angles of a rectangle are and what the area of a rectangle is? So it's actually very simple. So the area of a rectangle, as you probably have learned, is base times height. So the base of the rectangle, which in this case is 5, times the length, which is 3. And you would probably know that the overall area is going to be 5 times 3, which is 15, right? But we also realize that we're trying to find the area of this little section right here. So basically, that's the idea. We want to find this little section right here. And in order to do that, we have to look at the rectangle's area and remove these areas over here, like these 3 sort of quarter circles. And does anyone know why we know that they are quarter circles or comprise a quarter of that circle? Okay, so as mentioned before, a rectangle has all 90-degree angles. And if a rectangle has 90-degree angles, that means that this length, this little sort of thing right here, let me change the color. This angle here is 90 degrees. And I don't know if you learned this before, but a circle in total measuring from the center has a total of 360 degrees, which means that if this arc or this sector, which is what this sort of thing is called, this quarter of the circle has an angle of 90 degrees, its composition of the total area is going to be 90 over 360 degrees. Does that make sense to everyone? This is actually quite advanced geometry. So if we know that this piece has a quarter of the area of the entire circle, then all we need to do is to find the area of the entire circle in order to find the area of each of these little quarter sectors. And remember, we know that they're quarter sectors because each of these rectangles by definition are 90 degrees. So does anyone know how we can find the total area, the total radius of this right here, of this circle, right? The total area of this circle right here. Because we know that the radius is r. Make this a bit clearer. We know that the radius is, oh my gosh. We know that the radius of this circle is 3. Oh gosh. 3. So does anyone know how we can figure out the area of this entire little circle, centered as C? Because as we mentioned before, a circle's area is pi times the radius squared. Is any part of this unclear? Okay then. So what this means is that this little piece right here this entire circle has pi times 3 squared. And 3 squared is 3 times 3, which is 9. So this entire circle has an area of pi 9 times pi. But because, as we mentioned before, this only takes up a quarter of that entire circle, we have to divide that by 4. And generally speaking, when we're doing just math in general, especially for this kind of geometry, we want to keep it in fractions when there's a pi in it. So we just keep in fractions and say 9 pi over 4. There's not really like that strong of a reason to do this, but generally speaking, we do this because it makes it seem a bit simpler. And it's also easier to multiply it by other stuff later. But we now need to find the areas of these other sectors. And in order to do that, we need to find the areas of the totals of the entire circle. And in order to find the areas of the entire circle, we need to find the radius, which is going to be sort of this length right here. So does anyone see how we can figure out this length right here of B's circle? So here's a hint. If we mark this point as, say, E, then we can see that EC is actually 3. Because by definition, a circle, the distance from the center point C to any point on the circle is going to be 3. Because that we have defined the circle as having a radius of 3. So this length right here is 3. This length right here is 3. So that means that every single length is 3. And since that's true, we know that EC is also 3. And since we know that EC is 3, another property of rectangles is that rectangles' opposite sides on a rectangle are the same length. So for example, we know that AD is the same as BC, and CD is the same as AB. So because we know that, then we know that BC is also equal to 5. And if BC is equal to 5, if BC, like this, is equal to 5, and EC is equal to 3, sorry for the terrible handwriting, and EC is equal to 3, then what do you think BE is, which is this length right here? Does anyone have any ideas for that? So what that means is that 5, which is the total length, minus this length right here, which is this inner length over here, is going to be 2, which means that BE equals 2. And if we know that BE equals 2, then we know that the total area of this entire circle centered on B, like this circle right here, is going to be pi times the radius squared. And the radius, which we have figured out before because it is BE, the length, which is the length from the center to any other point on the circle, is 2. So we know that that is 2 to the power of 2, which is 4 pi. And since we know that this is 4 pi, if we split that, and as we remember, this is also this length, this sort of sector here, which is part, which we're trying to find is going to be a quarter of the total area of the circle. We know that it is, that quarter is pi. So on the bottom other circle, we also need to find this area right here, which is going to be BA minus another point, which we'll put here called F. So because we know that BF, since F is on the circle centered on B, then we know that BF equals 2. And as mentioned before, BA has to equal 3 because a rectangle, the opposite sides of a rectangle have to be the same. That means that AF equals 1. And that means that the circle centered on A also has an area of pi times 1 squared, which just equals pi. So then we have to divide it by 4, which gets turned into pi over 4. So now we know that we have an area, a sector that's 9 over pi 4 over 9 pi over 4, a sector that is just 1 pi, and a sector that is pi over 4. We can just figure them out using this information. So as mentioned before, we have to look at the total area of the rectangle to take away these little sectors. And the total area of the rectangle, as mentioned before, is 15, because that is how you find the area of the rectangle, base times height. So since we know that is 15, we just subtract all of these from all of these sectors to find that little area, this leftover area here. So we get 15 minus 9 pi over 4 minus pi over 4. And if we know how to simplify fractions, then we can see that this is actually equal to 15 minus 8 pi over 4, because 9 pi over 4 minus pi over 4 must equal 8 pi over 4, right? Because we just subtract from the numerators. And 8 pi over 4 is the same thing as 2 pi, right? Because 8 over 4 is just 2. And 2 pi minus, oh wait, sorry about that. Actually, that was wrong. 9 pi over 4 minus pi over 4, because we already know that's negative 9 pi over 4. Then it gets turned into 10 pi over 4, because we are subtracting 9 pi and we're subtracting another pi over 4. And that gets turned into 10 pi over 4 minus pi, which is just the same thing, which in the end gets turned into 15 minus 14 pi over 4. And if we calculate that, we get something that is extremely close to 4.0. And that means that the answer in the end is going to be B. So does that make sense to everyone? It's quite a complicated problem, but it uses relatively simple ideas. Okay, so now we're actually going to move on to a different oh my gosh. To a different thing. So it's going to be a kind of game. Called Sprout. So in this game, all you have is 2 points. And these 2 points can be connected by a line. But you can also connect a point to itself. And when you create a line like this, when you connect 2 points or you connect a point to itself, you create a new point like this. So you create a new point on that line. So in the end, but another thing is that if a point has 3 lines coming out of it, like this point, because we have 1, 2, 3 points, this one, and that one, that means that we have that point is dead. So if a point is dead, I'll just cross it out like that. Or actually I'll use red. So this point is dead, but the other points can continue connecting to each other. And in this game, people will take turns connecting lines. So for example, player 1 can connect these 2 points, creating a point here. And then player 2 can connect these 2 points, creating a point here. And now this point is actually going to be dead because there are 3 lines connecting to it. So if there are 3 lines pointing towards 1 point, then that means that point is dead. So then something else that player 1 could do is say like this. And once player 1 does this, this point is also dead. And points that connect to, you cannot connect a line between a point that's alive and a point that's dead. So you cannot do this. That means that a point can only have a maximum of 4 connections or 4 lines pointing towards it. So in this case, since player 1 did this, and then player 2 did this, and then player 1 did this again, that means that player 2 has nothing they can do. They have to do a move, like something connecting from this point, but they can't because there's nowhere the point can connect to. The point can't even connect to itself because when it connects to itself, it will have 4 different lines going towards it. And the objective of the game is to make sure you don't end up with no point that you can connect to. So in this case, player 1 would win because player 2 can't actually do anything right now. So does that make sense to everybody? Actually, for this, you can also see that when you connect these 2 lines, it also forms these other points here. So when it forms these other 2 points, player 2 can actually connect these. So that means that these 2 points are now dead because every time you connect 2 lines, it forms another point. And then it creates this other point here. So if we can remember this point, this one is player 1, this one is player 1, and this one is player, this one is player 1, this one is player 1. And that's pretty much, and then these 2 are player 2's moves. That means that the only move that player 1 can do is just this, connecting these 2. And now that we have just a single point here, that's just stuck here, these 2 points are dead. This point cannot go anywhere else, cannot connect to anywhere. So that is actually how Sprout, this game works. It's very complicated, but it's also very simple because it sprouts only from 2 points. So for a game of Sprout, does anyone want to try playing a game of Sprouts like this right now? You can connect between 2 points, just connect these 2 points, and then tell me which point you want to connect. So if we just look at these 2 points and we connect them together, then, okay, so how about this? Why don't each of you just try to think of a move that is possible in this case? So Joyce, can you think of a move that is possible in this case? So there are 2 moves that are possible. Well, there are actually 3 moves that are possible in this case. You can connect these 2 points. You can connect this point to itself, forming another point there. Or you can connect this point to itself, forming a point there. So you basically have 3 choices in this case. So do you want to see which one you want to do? You can do any of these. They all lead to a very long web of different possibilities.
Right one connected to itself.
Okay, so let's say someone does a move just connecting these 2 points together. Now all of these points are still alive because this one has 1 connected to it, this one has 2 connected to it, and this one has 1 connected to it. So now in this case, what move would be possible? So starting from this move, do you think you can connect to both of these other ones and to itself like this? So there are, in fact, 3 possibilities because this line can attach to both of these, and it can also go to itself. But if it goes to itself, then this point is dead. For the center one, it can also go to both of these, but it cannot actually it cannot actually attach to itself. Not only because the lines would cross, but also because if something like this happens, then it would have 4 going here. So you would have 1, 2, 3, 4. And because of that, that means that this point can only do something like that. And this last point can also attach to itself. It's basically just a mirror of the other point on this side. So basically, what this means is that we have all of these like this. And if we were to continue a game on until someone till someone wins, then we would do something like this. This would be something like that. So now we would have these final 2 points together. And now every single point, there's 1 point just left here, which is still alive because it only has 2 attached to it. But all the other points are dead. This player would lose. Now, for another system of this game, we can also start with 3 points. And if we start with 3 points, then this point can attach to both of these, and it can also attach to, this point can only attach to both of these like this, because it can't actually attach to itself after something like that. So that means that we can just connect these, connect these, connect this one, which will form something like that. And if this forms, and if we continue on, then eventually one side will win, either player 1 or player 2. And what happens with that is that we can also see the minimum and maximum number of moves. So people have done studies on this in the past, and it is because it is so complicated. You can see that there are so many possibilities, because every time you connect one, you create a new node or a new point. And because we can create all these new points, the amount of complexity that can emerge from just these two is immense. So yeah. So since you guys aren't going to participate, we will end this now. All right, thank you guys for coming.
Thank you.
Thank you.